Assalamu alaikum students. I hope all of you are well by the grace of Almighty Allah. I am also well. Welcome to our today's science class, and I hope all of you will enjoy our today's science class. Students, before starting our discussion, I want to ask all of you a question. Actually, I want to know, how are you spending your vacation period at your home? You know, some of my cousins have said that they are spending their vacation period by reading their favorite types of books. They read books, not only they read books, they used to continue their study through online devices. Actually, through online classes, they gathered their knowledge staying at home. And for this purpose, they have to use electronic devices. So I can clearly say that at this lockdown period, we are very dependent on electronic devices. How do these electronic devices run? These electronic devices run with the help of electricity. So students, today we are going to discuss about this topic. I think you can guess what will be our today's topic. Our today's topic will be what do you think? What will be our today's topic? Yes, you are thinking the right one. Our today's topic will be electric circuits and current electricity. So let's start our discussion. Electricity. Students, I think all of you are eagerly waiting to know what is electricity. Before starting our discussion, we have to see a picture at first. There is a picture. This picture shows you a battery, a very familiar battery to all of you. This is a pencil battery. This pencil battery has two sides. One side is positive and the other side is negative. This positive and negative, both sides are connected through a electricity conducting wire. Electricity conductor wire means that type of wire which can carry electricity. When you join both sides of a battery with this type of wire, electricity starts to flow. But still we don't know what is electricity. Electricity is one kind of energy. How is this energy produced? This energy is produced when electrons start to move from one side to another. After connecting the battery with such type of wire, electrons starts to pass from the negative side of the battery and it moves through the wire, and after covering the whole path, it reaches to the positive side of the battery. That means the motion of the electron starts from the negative side, and thus an energy is produced, and this energy acts exactly on the opposite direction of the electron flow. Electrons started to move from the negative side, but electricity starts to move from the positive side of the battery. That means always electricity flows in the opposite direction of the flow of electrons. This is called electricity. So, we can define electricity like this. Electricity is the flow of electrons around a circuit. But the important thing is their direction is not same. The flow of electron is totally in opposite direction of the electricity. Flow of current. Students, already you have come to know what is electricity. And now we are going to know about the flow of current. We know how does the electricity flow, but there is a question inside myself that from where does the force is created to move the electrons from one side to another side? What is the reason behind this? To know the reason, we have to see at first a picture. Here is a picture. In this picture, in the first line, you were seeing two tanks, tank A and tank B. These two tanks both are containing similar level of water. But in second line, you are seeing two tanks which don't have similar level of water. Tank A has higher level of water and tank B has lower level of water. If you connect the first two tanks with a pipe, there will be no flow of water because their water level was similar. But if you connect the next two tanks with a pipe, the water will start to flow from tank A to tank B because the flow starts from the higher level portion. Like this, if you see the two sides of a battery, you will find that one side contains higher potential energy and other side contains lower potential energy. This preserved or potential energy creates the force of movement of electrons. The side which has higher potential energy is essential to create the flow of electricity. That means electricity starts to flow from the higher energy region to the lower energy region. The electricity flows from the high voltage region to the low voltage region, but electron flows in the opposite direction. Thus, flow of current is occurred. We all have come to know that electricity starts to flow from the positive side of the battery. That means higher voltage region is the positive side of a battery. So we can define potential energy like this. Amount of electric work that has to be done to carry 1 unit of charge from one point to another is called potential difference between the points. Types of current. A few seconds ago we have discussed about the flow of current, and now we are going to discuss about the types of current. There are two types of current. One is alternating current, that means AC current, and the other is direct current, that means DC current. Alternating current is such type of current which changes its path with time. But direct current is such type of current which always flows in a straight way. It doesn't change its path. Alternating current is used in our home of our circuit. Not only home, the circuit of our homes, offices, schools and so many places. But direct current is used in only the devices of our daily purpose. Direct current is necessary to run the devices. But if we use direct current in our circuits, it can create short circuits or accidents for ourselves. I think the flow of these two types of currents will give you clear idea about the difference between them. There is the direction of flow. DC current. DC current is flowing in one direction, but AC current is changing its direction with time. The AC current which we use in our country changes its path 50 times per second. Students, now see a thing here. What are you seeing? Here you are seeing that the electrons are moving. The electrons are moving from one side to another side, and while moving they are passing a zigzag line called resistor. So I think you have a little bit idea about resistance right now. The function of this resistance is to making obstacle in the flow of electrons or electricity. The devices that we use in our daily purposes are not in same capacity of electricity absorbing. Some devices need too much electricity in great amount, and some devices need a little amount of electricity. That's why we have to reduce the flow of electricity according to the demand of devices, and the function is done through the resistance. Resistance is like this picture. It is the physical look of a resistance. There are color code in a resistance, and different devices has different value of resistances. The definition will be like this. The property of creating obstacle to the flow of current is called resistance. Now I am going to show you a very interesting picture. This picture is very funny. There are three persons. One person is pushing another person, and the third person is trying to making obstacle in the path of his moving. Blue color shirt wearing person is indicated as volt or voltage. Green color shirt wearing person is indicated as resistance, and yellow color shirt wearing person is acting as current. If the blue color shirt wearing person push more and more, the yellow color shirt wearing person will try to pass in earlier or try to pass very fast than before. But if the green color shirt wearing person starts to pull more than before, it will be difficult to pass for the yellow color shirt wearing people. That means If you increase voltage, current flow is increased. If you increase resistance, current flow is decreased. It clearly gives you an idea that these three things have relations among them. This relation has been discussed with a scientist, and the scientist was Ohm, and the given law of him is known as Ohm's law. So let's see what is the Ohm's law. Ohm's law is, at a fixed temperature, the current flowing through a particular wire or conductor is proportional to the voltage difference between the two ends of the conductor. That means V is proportional to I. V is indicated as voltage and I is indicated as electricity flow. This relation is given from scientist Ohm. Here is the triangle of Ohms. V is equal to IR, I is equal to V by R is equal to V by I. We can state that voltage is equal to electricity flow into resistance, or we can say like this too: electricity flow is equal to voltage by resistance. Or this will also be said that resistance is equal to voltage by electricity. We have come to know about the types of current, but now we are going to know about the types of circuits. Before knowing the types, we have to know what is circuit. This is circuit. It is a very simple electric circuit. Actually, when you connect an electronic device with a battery through an electric conducting wire, that means it is a simple electric circuit. It means the simple pathway of electricity flow is called electric circuit. And this circuit is of two kinds too. The first kind is series circuit. In such type of circuit, the devices are connected serially. That means one by one. The first bulb is connected with the second bulb, and the second bulb is connected with the third bulb. One side of the first bulb is connected to one side of the battery, and the third bulb's one side is also connected with the other side of battery. In this type of circuit, the voltage is not same, but the electricity flow is same, as the two sides, actually positive and negative side of the battery, is not directly connected with each bulb. So the potential difference is not same for each of the bulb, but the electricity flow is similar for each of the bulb. Now we go for the second type of circuit. The second type of circuit is parallel circuit. And this type of circuit is created with the parallelly joined devices. When you create a circuit joining the devices parallelly is called parallel circuit. In such type of circuit, voltage remains same, but electricity is not same. It is different, because all the sides of It means positive and negative side of battery is directly joined with each of the bulb, that creates similar potential difference for each of them. But the electricity flow is not same, because on each point or each line, the electricity flow is divided into two parts. That's why all of the devices does not get the same amount of electricity. Now we are going to discuss about this thing. What is this thing? This thing is ammeter, and this ammeter is used to measure the electricity flow. You are seeing that ammeter is connected. One side of ammeter is connected with the devices and the other side of the ammeter is connected with battery. And this device is only used to measure the electricity flow or the quantity of electricity flow. Now we go for this device, and this device is voltmeter. Voltmeter is only needed to measure the potential difference, actually the difference between the two sides of a battery. So the device or the voltmeter is connected with the two sides of a battery. I want to emphasize one point, that ammeter has to be joined on a circuit in series position, but voltmeter has to be joined parallelly in a circuit, because if you want to know the voltage or potential difference accurately, you have to join the voltmeter with the two sides of the battery. So it is very important to know how will you join ammeter and voltmeter in a circuit. Obviously, you have to join ammeter in series circuit or voltmeter in parallel circuit. If you join voltmeter in series circuit, the voltmeter will be melt. Galvanometer helps us. But how? This galvanometer helps us to know the measurement in ammeter and voltmeter. Let's see a picture 2. This is a picture of a circuit. This circuit contains a bulb, a switch, a battery, actually 3 batteries together joined, a resistor and an electricity conducting wire. There is also a picture. This picture has also a circuit, and this circuit is containing a bulb, a switch, a battery. But what is the difference? Difference is, at the first picture you are seeing resistor, but in the second picture you are seeing another type of resistance, and this is called fuse. It is like a wire. Resistor has different types of value. Fuse has also different types of value. The value of resistance is different for different types of devices. Like a device which needs only 10 ampere current and another device which needs 5 ampere current, they need different types of resistance inside their body. Fuse is also one type of resistance, but this resistance is used in the circuit of our home. If the fuse becomes melt, we have come to know that there was excessive electricity flow in our circuit, and this fuse has saved us from short circuit accident. So the fuses are very important for our daily life. What can be the definition of fuse? The definition of fuse can be like this: an electrical safety device built around a conductive strip that is designed to melt and separate in the event of excess current. Now here is table for all of you, and this table will help a lot because here are unit, symbol and formula for these characters. Electricity's unit is ampere, A, and the symbol is I. Formula of electricity can be like this: I is equal to V divided by R. Voltage, unit is volt and symbol is also V. Formula of voltage is V is equal to I into R. Resistance, unit is ohm and the symbol is beside like this. Symbol of resistance is R, and the formula can be R is equal to V divided by I. Series circuit doesn't has any unit or symbol but has formula. In series circuits, if you join so many devices or so many bulbs like the pictures, each device will contain another or other resistance. So the resistance or the total resistance will be like this: Rs is equal to R1 plus R2 plus R3 plus and so many resistance. The resistance will be like the number of the devices. Parallel circuit. In parallel circuit, the formula will be like this: 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and plus so many resistance like this. So students, thanks to all of you for attending my class, and I hope all of you have enjoyed a lot. And please do your works what we have given you to complete at your home. Thanks to all of you again before ending my session.